Perfect. Thank you so much. Awesome. Well, thank you everyone for joining our Docling community call for April 15th, 2026. Today we have George Heiler here to give a presentation. We're probably going to go ahead and start with his presentation before we get to some project updates and announcements. So, George, without further ado, would you like to take it away?
Okay, now you surprise me a bit. I was thinking we'd start with project updates, but let me share my screen. I think you should be able to see something, right?
Good.
Looks good.
Perfect. Well, then let me test my clicker, that it actually can work and I can continue with slides. Perfect. That also works. Nice. So, thank you for inviting me to the Docling sessions, community office hours. Today, I want to share a little bit how I'm using Docling and extending it for a specific use case. I'm Georg and working on a new, very early stage startup called Jubust, where we are analyzing chemical patterns and basically extracting molecules. Today, we will look into the technical, let's say, magic behind this and what you could perhaps reuse in other open source projects on your end. So perhaps, who am I? I'm one of the co-founders of this startup, as mentioned, was actively supporting Docling in the last months or even, I think, year. I'm also a contributor to Metaxy. Today, we will hear a little bit more about what Metaxy is and why it can be useful. And I'm also working in research and industry settings around telecommunication and complex systems. In very short, Docling is a good, let's say, baseline, but chemical patterns are challenging. We will start by explaining what can already be done, how this can be then improved by adding Metaxy to the mix with regards to selective recomputation, and then detail how the quality actually can be achieved with an active learning approach. Oh, my mouse. Okay. Chemical patterns themselves can be quite a demanding benchmark for AI, because unlike traditional documents or bills, they don't just have simple tables. Some of them have really complex tables that include the image or visual graphical structures of the molecules, and they're a bit all over the place. Also, they can be really long. That means time is really expensive to process. Some of them have 1,000 pages. Current solutions don't really do the provenance well. So systems like Reaxys usually just have a link to this particular document contains some molecule, but it's not like you can click the molecule and it jumps to the source document. When you want to understand the context of how things are connected, having this and also in order to verify results, this can be quite critical. What you see here is a screenshot of this sort of platform that we are creating. You can see the molecules, and when you basically click one of them, the bounding box of a particular place in the source document will open up. Not just that, it's linked to the properties of the molecule. So if you are only interested in specific molecules or high impact ones, you can basically filter the table and then quickly jump to the places of relevance for you. So this is all based around evidence and provenance. And in order to achieve this with high quality for us, active learning is a key element. So there are certain AI models in place that generate certain input that is reviewed and is increasingly generating even higher quality AI input and streamlining and improving the review process. The output is then something machine readable that can be used for different use cases. But how are we making this happen? This community here is the Docling community. You already mostly know Docling very well, and the Docling is a great foundation. This is the parsing layer, or one of the parsing layers that we are using, to be precise. I briefly touched on Metaxy before. Traditional data pipelines face the challenge that the computing paradigm changed, especially when looking into AI and multimodal. Traditionally, you had, let's say, an Excel table with 100 rows, and each of them was super cheap. In fact, the whole table was super cheap to recompute. So throwing it away and recalculating that was a breeze. But with AI compute, where the individual row is tokenized by talking to some LLM, or GPU hours for, let's say, Docling documents, where one row is perhaps one document with, let's say, 1,000 pages, recomputing a single row can be quite costly. But traditional systems were batch-oriented and either recomputed the whole table or perhaps a partition, like a coarse-grained subset of a table. So frequently, a lot of unnecessary compute was triggered. This leads not only to long waiting times, that means less experimentation, but also wasted energy. With Metaxy, we hope to solve this problem for many people. It's an open source project, and we will in the next minute see how it works. Ray is an element that makes the thing scale, and Dexter is where basically tying everything together. Some of you in this round might have seen also the recent announcement of Red Hat. Basically, they described a sort of similar architecture around Docling and Ray. They were lacking Metaxy. I hope they will add it, because it will actually be beneficial for them. So what works well? In short, basically, the really complex document tree of Docling that is very faceted around also complex documents, graphical elements, tables in tables, around tables, and images again, is a good foundation. And on top of this, we can then build custom things or add integrations around chemical OCR, for example. What tends to be a bit challenging from time to time is parsing these weird tables into one combined table and then merging the context correctly. But we have developed some heuristics and annotations that streamline this process by now. So I was teasing Metaxy, but how does it actually work? Well, first of all, we have to define sort of a feature, like we call it, that is sort of more or less a DDL, or this like columns that you want to store. Then Metaxy will figure out automatically what is stale and tell you, or your orchestrator, what to recompute. And then you would only execute the diff. So what Metaxy does is it carries a data versioning dictionary where for each record, this metadata is tracked. Or put into different terms, most of the people here probably know Airflow or Dexter or Uzi, these kind of systems. If they're done well, like for example Dexter, they have a nice graph representation of your data dependencies, of the objects and how they are connected. But these systems only track the graph on the level of the whole table. What Metaxy is doing, it tracks this graph for each individual record. And for each record, Metaxy stores a data version and a code version and additional metadata that might be valuable. So for example, you can disambiguate real documents and test documents or whatever other metadata you have extracted. So you can quickly make use of certain extracted information from the documents, because it's not just in the multimodal system, but stored in a nice database. So in different terms, what we have here is something like column level lineage. I like to call it topological lineage, but on the record level. And this allows Metaxy to basically skip things that are not necessary. So if you, for example, have a video that would have an audio part and a video part, and you only change the audio part, Metaxy would know that it doesn't have to rerun the video transformations. How does this look like? Well, we already understood that Metaxy is there for the diff, Ray for running, Dexter for operating. If we look at a small minimal code example, we are talking about Docling documents, so let's assume we have some converted documents here from the Ray badge. We would first call the resolve update method, which would tell us some documents were added into the input directory or some were removed, and then perform the Ray-based document conversion. If some were removed, perhaps because of some privacy reductions, we could actually then trickle down and remove them in all the steps of the pipeline. If fresh ones are added, we will compute them. But if you think about a graph of multiple steps of processing, where it gets even more interesting, you can at any step in the graph start to branch this graph and on a desired subset, continue a subsample execution. So the topological cache allows you to experiment more quickly. And what would happen then in this particular case, Ray would then store the result and basically perform, let's call it the checkpoint on the Metaxy side, and store that this particular multimodal file was computed. Perhaps this Docling JSON document was stored in an object store, and would checkpoint to the Metaxy database that this document was processed and some metadata was extracted. Before actually I move on, you should know that Metaxy is an open source library. It is really flexible, so you can plug the backends from DuckDB to Postgres to Iceberg to ClickHouse to BigQuery. There are many implementations. So I want to encourage you to try it. At least give me a star on GitHub for it. But ideally try it and then maybe make use of it and save some energy.
Oh, so Georg,
yeah,
Metaxy is mapping only on structured. It's the only structured databases? Because I'm starting to just I'm not aware of the depth of it, but like document databases, vector databases, and these type of things would be extensions? Is it already supporting that? Wouldn't it make sense? What is your opinion there?
Yeah,
just so, for me to understand.
Yeah, thank you for this question. So traditionally, the challenge is that multimodal documents are very time consuming to process. And the metadata about these documents does not follow any structured way how you would want to store it. Recently, there have been some developments. Some of you might know LansDB, for example, or a ton of other multimodal databases. Some of them are very proprietary, some are very opinionated. But they managed and identified certain ways of how to make this somewhat easy. What they are lacking, in my opinion, is the cohesive connection of this overall graph that is tying things together and that allows for this topological checkpointing that can then save the computation. This is one challenge. Okay. Second challenge is you're locked into the specific technology. With Metaxy, you can say, hey, I want to store my, let's say, Docling JSONs in S3. I want to store the metadata about these documents in DuckDB or DuckLake, for example, at least for trying things out. And you can run this very small. But when you run in production, you might say, I want to go to ClickHouse or BigQuery or something similar, and I store my metadata then in these types of systems. Now, the second part of your question was embeddings. You have, like, if you look at traditional structured data, embeddings are one or a couple of orders of magnitude larger in size. And the traditional database like Lance for these type of data claim to be really great. And then you have the raw documents, which are even more like a video file, much, much larger, and usually just referenced as an object on a blob store. So with Metaxy, for example, we do have an integration for LansDB. And if you prefer to use LansDB for what Lance is good at, you could use it for that. But you could also say, I prefer Postgres because it is really easy to operate for my company. And you could just store the embeddings in this particular storage system. So let's say if you use DuckDB, DuckDB has a specific and quite honestly optimized version of storing embeddings. You could just use that for that. If you were to use DuckLake, you could then easily sync this out into an Iceberg compatible DuckLake system and then use a very flexible system of query engines to then query them. I hope that is answering your question.
Yeah. Okay. No, I think it's a good starting point. I'm interested now.
So the idea is to really separate the data and the metadata, but make it pluggable and cacheable easily.
Yeah.
I was recently contributing certain things to the Docling community around some new VLM models, around rapid OCR. Then also was creating Metaxy.
How to do that and what?
Okay, not a question. Okay, so Ben recently was creating.
Somebody was just talking.
Okay,
apparently.
All fine. And then I was, as I explained, with a friend creating Metaxy. In fact, Daniel was doing the largest part of the work there. He was just supporting on the side as much as I could. He's a phenomenal programmer, and really, I think Metaxy is really cool. But another project that could also be of interest to this community, at least the more researchy side of things, or people that are training models, is Dexter Slurm. A lot of the traditional model training happens in HPC environment. A lot of them are based on Slurm systems, and I personally find Slurm a bit of a turn off because it is a bit annoying to use, lacking a little bit of a telemetry that I would expect from a modern orchestration system. This is why I created this Dexter Slurm integration, which allows you to rapidly prototype something locally in the local execution mode, and then repoint by a config flip to Slurm execution. But not just this, you would also get nice bootstrap of the Conda environment on the remote system. You would also get all the nice logs that you expected from something like Dexter. So you could even use structured logging there and then log your metrics. So the three most important points from my side are really preserve the structure. It means also from the provenance perspective, but also when thinking about the metadata in Metaxy, think about how these systems should be structured. You will benefit a lot from it. Recompute really only what changed, save the energy. And make sure that reviews are possible and fast to be performed because the evidence is closely connected to the underlying data. With that being said, would happy to answer some more questions if there are any.
Quite nice. Is there somebody that wants to ask questions? Otherwise,
good morning, good afternoon. Jean-Marie speaking from IBM. Peter.
hey.
Yes, I was looking at this, recompute only what it is needed, okay? And that's something that I did built in the first Docling origin for the StreamSet platform, just for you to know, okay?
Nice.
Also, I have a question about this JSON. I mean, what was the talk just before? Most of the time, I mean, documents, they are coming from different, data sources, okay? They could be document within a log of a database. It could be any type of document, basically speaking. But the Docling JSON, okay, if you want to store it somewhere, maybe you don't have to store it. You just have to map where the JSON is using some of the database technologies available today, which can use an external table structure for you not to have really to inject anything in your database, just using the database to query the content of this, I would say, external table data elements. That's just something that I was thinking about.
Yeah, I mean, this is a neat possibility, but that depends a bit on your particular system and structure.
Yeah, definitively. But I am always thinking, I don't want to get, handcuffed with a specific, I would say, platform provider. Then definitively, if you have a central storage agnostic to up to a certain extent, okay, you could have a central storage agnostic, map it in Snowflake, map it in Google BigQuery, map it in Delta Lake, and you don't have to move anything. Basically speaking, you consume from where the data has been stored. The only challenge is really to have a good, I would say, storage management and to have a nice, I would say, file system, I would say, setup for you to not to have to struggle too much after that.
Yeah, so basically, I think you can see the screen of Metaxy here. I mean, it's not really an answer to your question, but basically Metaxy has, for example, one storage backend as Delta Lake, one is Iceberg, one is BigQuery, one is DuckDB. So this already allows you to very, let's say with a diverse set of backends, query metadata that you would like to, if you don't want to be logged in, you can basically use the various systems. Assuming your real data always stays in, let's say, the S3 bucket, you can then use various systems to query it.
Yeah, very much. Exactly right.
Okay.
And also Metaxy has certain, let's say, non-metadata operations. So if you would want to rewire the graph because you changed something or because you want to port it into another system, perhaps, it could also assist you in switching your backend store from, let's say, DuckDB to BigQuery, perhaps, or whatever system you want to use. I see one question there from Marsha.
Go ahead, Marsha, go ahead.
Was I given permission? Oh, sorry. Sorry about that. Sorry about that. My connection, I just joined. My connection is a bit unstable. I apologize. So it's my first time attending office hours. So I'm just asking the question. Is the Metaxy usable with SPSS? Will there be a recording provided? And just if a quick recap of what I've missed so far, please. I'm so sorry.
Okay, so perhaps two questions. If I got you right, the question was, does it have a plugin for SPSS with statistics software? Did I understand this correctly?
Right.
So I don't know if SPSS can read, for example, let's say Delta Lake tables. So if it can, then you could use it. Or if SPSS can query DuckDB databases, or if it can query, let's say, ClickHouse or BigQuery, then you can basically retrieve the metadata from the database and read the document in your system of choice. But traditionally, or by its nature, Metaxy is developed in Python. So if you want to switch to SPSS, which I believe is a different language, you could read the state store of Metaxy in the language of SPSS. But the best experience and this resolve update function that I explained to you is currently only available in Python. But you would then have to sort of implement that on your end. The metadata is still flexibly accessible to you. And because you asked for a recap, so just really short. So basically what we are doing is we are analyzing chemical patterns. We are extracting the compounds and the data and structuring that. And behind the scenes, we are basically using, for example, Metaxy to save money, energy, time, but also to allow or increase basically experimentation, because we can branch this graph at any, let's say, level. And I don't know if someone here in this round is also using videos, but for some kind of where do I find it? I think we have it in the concept section. So here, when you define, we have specific lineage types. So for example, if you have a video that has to be sliced up into pieces, let's say 30-second snippets, because the models can only process these particular chunks, Metaxy also allows for this expansion and later aggregation if that is needed. Hope that answers your two questions.
Yeah, okay. I have a few other questions, like specifically for the chemistry that you were talking about. Like, how do you see that actually working? So we do have, like, in the data structure, we have support for the chemistry molecules, obviously. We have also our own extraction models that we want to more tightly integrate. So how far do you want to go with that, and how does the document data structure or Docling document maybe then propagate towards the graph that you guys are probably building, I suppose?
Yeah.
Right.
So what we are currently having is sort of Docling is one of the key extraction engines, and others are sort of normalized to this representation. And they usually have more than one OCR engine to produce a raw output, because this particular type of document is sometimes very strange for some of the models. So we are having some kind of fusion of these models for the various steps in the pipeline, certain annotation and active learning steps, where there's a review gate, and when the data is produced. With regards to the ChemOCR, for example, we are using this field that you created in the structure, and then running some ChemOCR models on top of that as well. But this is something we have not yet focused in too deep. We are more currently focused on getting the end-to-end pipeline running smoothly, covering more edge cases, because even there for the tables and doing this right and connecting the molecules and the tables, there are many, many edge cases. If you want to do it right, that you have to cover.
Yeah.
So can you help me understand a little bit more about the value of Metaxy as far as version control and only rerunning parts of the pipeline or only rerunning the pipeline for certain documents that you need to for, say, your chemical patent use case?
Okay, so for the chemical patent use case, basically we have a pipeline of many steps and they're related. Sometimes there might be a bug fix or edge case that happens somewhere on the left side or upstream side of the graph. And with Metaxy, I can basically easily branch my system. So I don't have to perhaps rerun the time-consuming OCR step, but I can create a fresh empty state and work on the document fusion step that is in an intelligent way combining the different OCR models. So I can, in my pipeline, isolate the state changes and then rerun only what changed or what should be tested on a specific subsample of a subgraph to iterate quickly. Is this already what you wanted to hear for the documents?
Thank you.
So we are not basically saying one document has many tables, Metaxy should track the tables. This makes more sense in the video scenario, in my opinion. We use Metaxy on the level of documents for now.
Thank you. Yeah, that helped.
Cool.
Great. Well, thank you so much, Georg. If there's no other questions, we can go ahead and move on to some project updates.
I think I just have like one comment here, right? I don't think we already said it, but I think Georg will become actually also a vetted committer to the Docling project. So it's one of the first from the outside that we're pulling in, and so really big congrats. And I hope we will have many more, maybe of the people that are joining here that we can pull in. So big congrats.
Yeah, thank you also for reaching out.
Yep. Well, I mean, if you do PRs and I see like if you start doing PRs on Sunday, then you keep me busy. Then at some point, we'll pull you in. No, it's a great collaboration and just love it. Just love to have you on the team, basically. So
thank you. And as I said, I hope what I shared is useful for more people, especially also Metaxy. And
absolutely.
Looking already forward to the next part. And if you want to reach out because you have some questions, I think you have my contact details now. Happy to chat and in more detail.
Perfect. Thank you.
Sorry, where are those details? I might send an email.
If you don't have them, you can. I will put something in the chat. I think that's maybe good. I thought you have them.
Thank
somewhere.
you. You check the Docling LinkedIn as well. He's tagged in the most recent.
Yeah, exactly.
Post.
This is what I thought, but I will send you.
Yeah.
I will send you something into the chat. So basically, there's on one side my website where you can connect with me, and I will send you also the link to the slides that I just showed, so you can browse them on your own cadence.
Great. Thank you so much. Okay, so we have a couple of updates to add for Docling. The main one right now is going to be the new Docling agent repo. So it actually lives under the Docling project. It is currently a beta repo, but the point of it is it's a Python library that allows you to use agentic applications on the Docling document format, right? So it brings these agentic workflows to the Docling ecosystem. The input is just a Docling document in, and then the output is Docling document out, right? So the library itself just does operations on the actual Docling document. It's also model agnostic. So if you've heard of Malay already, it's another open source project. It allows you to use any model you want within this Docling agent library. There's actually 6 agents within this Docling agent library. There's a writer, editor, extractor, enricher, RAG, and orchestrator agent. So all of these are agents that can then run operations on the actual Docling document structure itself. You can see very simple to run, just 3 lines of code. That doc is going to be your Docling document, and then you can do agent.run on the actual Docling document itself. The point of the Docling document architecture is, the Docling agent architecture is a chunkless RAG approach, right? So with traditional RAG, you're focused on chunking and embeddings to accurately retrieve relevant context for your retrieval and then generation. With Docling agent, the goal is to be able to use Dockling's native document structure, right? So for those of you, I imagine all of you guys are already familiar with Docling. Docling is highly structured representation of the document, right? So how can we actually leverage that structure during the retrieval process? And so the agents are then able to navigate through the Docling document structure without the chunking embeddings, right? Traditional chunking embeddings, which then allows it to retrieve relevant context through just navigating through the actual hierarchy tree of the Docling document. The orchestrator agent also allows for LLM-based planning. So given a query, it can actually select the right agent. It means that you don't actually have to go and pick the correct agent if you don't want to. And then it operates on your local document library, and it can cache the converted documents after enriching them so that you don't have to reprocess. And there's also a included CLI. It's still a very new repo. There's actually 6 examples there that you can try out. We'll have a workshop available for the Docling agent soon as well. But because it's a new repo, there's any feedback or contributions are very much welcome. And there is a GitHub link to the actual repo down there. If you just look up Docling agent under the Docling project, you should have no trouble finding it. Peter, did you want to add anything to this?
No, I think you said right. I think there's some caution to be done. So it's not like perfectly cooked, but we try to, always put already everything in the open so people can actually experiment and look at it, what we're trying to do. We're not trying to reinvent a new agentic framework that does everything, but what the purpose of this capability is to actually, what Docling is for conversion is basically a one-shot. What you basically want to do after you have your conversion, the next logical step is you want to do something with those documents, you want to leverage the actual deep semantic structure that Docling gives to the maximum, right? So what we basically want to make sure is that the Docling agent knows by default all of the structure that the Docling document gives and exploits that to the maximum in order then to write documents, edit documents, extract information, etc., etc., etc. It's also for us a playground to see, okay, what are actually the structural elements we need to introduce to really have a very nice experience. And we also want to make it as a package so that you can actually say, okay, I can have Docling that can do the conversion, and then afterwards I will do something on my documents, and that is basically pip install Docling agent. Of course, the agent can also convert documents, but it should do more than that. It should start extracting information. It should start cleaning information, summarizing, all of these type of things that you would like to do downstream, essentially, and have already some complexity there. We leverage the Malaya package in order to enforce some rules. We will also expand to some more simpler things like light LLM and all of these more like other gateways, such that we can really experiment very quickly. And I think the next 2-3 months, we're gonna use this really as an experimentation. It's still not like it's version 0, but there will be quick iterations. And for me, this is the jumping point to really then do the Docling graph, where we will start building ontologies from unstructured data, essentially, right? So there's a structured approach here, but as always in the Docling organization, we try to do all of this experimentation straight into the open, so that everybody everybody can look, understand, maybe contribute, have good ideas, and all of this type of stuff. So it's a natural evolution of conversion. Yep. Go ahead.
Peter, I have a question for you.
Sure.
Did you ever consider, maybe it's already done, okay? Excuse my ignorance here, okay? But
Sure.
all of this, I mean, document, I mean, these are, you have metadata, you have data, you have, a lot of, I would say, information, make long story short, okay, available when you are using Docling, okay? But did you ever consider to connect Docling with a knowledge catalog?
Yeah, so that's exactly what the Docling graph will do. Okay, so
are you going to provide this as I would say independent product, or do you plan to have adapter or connector for, let's say, IBM knowledge catalog or any kind of catalog that is currently available on the market, or does this provide a kind of open source centric solution?
That's an excellent question. The connectors is a never-ending story, so for sure we will want to do part of that in the open source, but it will never be complete. What I'm more interested in is to start thinking slowly about how we can build up world ontologies that will allow us to give deep semantic context in the context window.
That is really important, because in the era of AI, the semantic is probably our first and center. I mean, if you want really to leverage AI and agent, no semantic, there is no point to do AI then, no?
Exactly. And what we are trying to unlock with this technology is that you have all the building pieces so that we can jointly build an open source common world ontology, let's say. But of course, that can never contain all the knowledge of, very specific, let's say, secretive knowledge. But it should be in such a way that you can take the same technology, run it for your own business, build your own ontology, and then see like there are going to be connection points with the public ontology. And so then you can actually start doing very interesting experiments. Essentially, you can see how much knowledge is really proprietary. You can see how you can leverage in the public ontology, etc. But you see, like, all of this is very, very simple, right? So you start from a very high quality document, or high quality ingestion, be that movies, podcasts, scientific papers, PDFs, financial reports, whatever. That's where you start from. Then you need to have an agent that starts to think about that and starts to find what is really important, summarize it. And then you need to have a graph that is going to connect all of this up. And it is going to say, okay, this is something I don't know. I need to expand that. And this is already known, so that I can already leverage that. And sometimes you will have, synonyms, translations, etc. This is, again, stuff that needs to be done properly, essentially.
I will share one of my current use cases with you, and you will tell me what you think, because it's everything at once. Okay, we go from ingesting documents to understanding what the content of the document is, and then to action the content as soon as we understand it on something else. Okay, I will share with you. Okay.
Super. Yeah. Absolutely. Yep. Go ahead, Benjamin. So, whoever else has his hand up.
Oh yeah. I was just kind of curious about a little bit more about the chunkless RAG, about exactly how the AI agent accesses that and sets up the query. Is it like a graph database that you've got there, or is it semantic search? Are you doing like a keyword search, a hybrid search?
That's all of the things we're kind of exploring. The current case we're doing is leveraging. So the Docling document itself is a tree structure by itself, right? And a tree structure is just nodes and edges, but very specific. It's not just a graph. It's like it's a hierarchical graph essentially, right? A tree is a specific part of a specific. The tree is a special graph, right? All trees are graphs, but not all graphs are trees. And so on each node of the tree, we basically start attaching summaries. We're thinking of adding also keywords and stuff like that. And then using those summaries and keywords, we let the LLM of the agent just reason what it should read from the actual document, right? So think about it like, how do you go and read the document that you need to look up? Well, you go to the table of contents, you read first the table of contents, then you find a page. Using that page, you go to the actual page where you read something, right? Very similarly, you can actually do the same thing with the chunkless RAG. Instead of like chunking everything and then go and embedding it, what you're basically saying is reason over the structure to follow, the tree down to the actual sections that are relevant. Right.
Then basically speaking, you are reading a DAG and then you place the DAG, correct?
Yeah, DAG is another word for tree. Yeah.
Yes, but basically speaking, you established first your, I would say, the trip. Okay.
Yep.
Where should you stop and what you should do at every stop?
Correct.
And then you are using it as a guide for you to execute the real data extraction.
Correct.
The way that
Correct.
it to be. Okay.
Correct.
Okay, I got it.
Correct. Yeah, that's exactly right. That's exactly right. Yeah. So that's pretty much it. Does that answer your question?
Is there also you brought up the example of like table of content for like the highest level of the tree. Do we also have like a version of that for all of the documents, like a view of like document A, document B, document C?
Yes, in the Docling agent, you will already find the concept of a library, where we basically say like we basically attach summaries. We don't yet have keywords. We're trying to add this now. But where you have basically summaries for documents that you say, which document should I actually read, right?
That could have a lot of bloated data, for that could fill the context window fast. I would think if it has, maybe there's 1,000 documents and it has to look at 1,000 summaries at that level of the tree.
Yeah, no, of course. I mean, again, that's what I said. It's like that would not be scaling like to, but then you can always start saying, okay, can we like group things, right? Like there might be documents about there might be scientific reports about the document processing. There might be manuals, but at the end of the day, everything that you always have is, you can always start grouping more and more and more. And I think what we're trying to figure out is there a good way to, how shall I say, to actually structure all of this organically? To a certain extent, you saw what Andrej Karpathy was coming out with, like this Wikipedia that he was writing on its own. It's also going into that direction again, right? So, I mean, we're not saying that we're having all the same. At the end of the day, a lot of people have the same kind of ideas. What we are trying to do, though, is to say, can we get away with having to make decisions even on what, how to chunk, what embed, for storage, etc., that you want to do.
Okay, yeah, thank you. And I'm pretty much done. I just want to say, I mean, maybe you embed each of those summaries, and the first level is a semantic search to find the document that has relevant information, and then from there, the AI agent can find can look at the tree structure.
Sure. There could be some hybrid method. Yeah, absolutely.
Yeah, but that's it. Thank you.
Yeah.
Before we handle the last couple questions, let's just go through the last few slides so that we can put up some nice information. So there's a couple of other upcoming or in progress works here. I won't go through all of them, but if you have any questions about them, feel free to reach out. And then I'm not sure, Peter, how much you wanted to talk about this specifically, but as a bit of a teaser, there will be a hosted Docling service that will be released in the next couple of weeks. Keep an eye out. Keep an eye out on the LinkedIn as well. There will be a big announcement, and you should be able to sign up for a trial within the next couple of weeks. So there's that. A couple of events coming up that Docling will be present at. If you are in any of these cities, feel free to attend the events. We'll be very happy to see you there. And there's a new Slack within the LFAI and Data Slack channel. There's a new Docling Slack channel within that channel. So if you scan that QR code, it should take you to the sign up link for the LFAI and Data Slack channel. We'll be moving a good amount of communications there, as that is like the formal LFAI and Data communications channel. We won't be removing any of the current channels at the moment, but as more and more people join, we may reduce activeness on those other channels. But yes, thank you very much. And any other questions we should have time for?
Yep. Georg, Ravi?
Well, my question was around quality. So we were talking about this graph. And from my perspective, what I shared before, I care a lot about quality. How do you, on one side, have this agent that magically solves the problem, but sometimes it will maybe not solve it alone, and you need additional steps or some human-in-the-loop interaction to, let's say, the multi-table problem that might be challenging and not pass correctly initially from the agent, handle that. So is there some correction step in the graph, or would an external process have to take the graph, fix it, then provide the corrected graph, and then the agent would continue? What is your take on that?
So my initial thing, so there's two approaches to this, is also because sometimes it will make the wrong decisions. So it can go down. You can do two approaches. Either you say, I do depth first, or I do breadth first, basically, right? So depth first is I first go all the way down. Do I find it? No, I go back up the tree, and then I say I go to the next one, that the next logical thing that potentially could solve it. There is also the breadth first search, in which you could leverage basically multiple queries at the same time of the LLM, right? And you just then try to. This is as if you would have like multiple chunks that are being retrieved, and you would consider to generate basically an answer based on the multiple chunks that you are retrieving. To be very honest, I don't really have a good answer to that one. I know that Caesar, that is now running or is going to OpenSearch Con, or is flying at least to Prague now, he's running actually a first evaluation where we're doing a one-to-one comparison on big documents of traditional RAG versus this chunkless RAG approach. And this is on the Vidore dataset from NVIDIA, basically. So just to get us a bit of an idea. And then we're going to basically take it from there. Again, we're publishing this in this forum also to have an open conversation. So it's not like we're basically thinking through the process in open source with the community. And I'm happy to get all kind of ideas and maybe collaborate together just to make this work. I have a strong hunch that this is going to solve a lot of dirty issues that traditional RAG has, but it's going to introduce different ones, and I think we can just think this through basically together. That's kind of where I'm sitting. Yeah. Ravi, you have another question?
Yeah. Hi, Peter. Thank you.
Sure.
Thanks for scheduling this.
Yeah.
So I have a couple of questions on this Docling agent architecture. So right now we are trying to implement document extraction using a doc converter, and another option is a doc extractor. So apart from that, if I go with Docling agent, so I mean, like, can I use Docling agent instead of them directly?
So, say again, sorry?
I mean, like, instead of using doc converter and document extractor library, directly we can use Docling agent architecture, and we can extract the content of the document, right? I mean, and we can ask the queries to get the expected
that's
whatever
the idea.
we want.
That's the idea. Yes. That's the idea. I mean, again, exactly for the reason that you're saying, right? So, okay, we provide Docling. All right, good. So you can convert, and now everybody's writing their own stuff on top, which is totally fine. Nothing against it. But I see a lot of recurrent patterns where everybody's doing the same thing. Okay, convert, and then, I want to actually ask questions about it. And so all of this code gets rewritten and rewritten and rewritten. It would be just 10 times more easier to just pip install the Docling agents as opposed to pip install Docling and then just ask your question and be done with it, right? That's kind of the idea, right?
So So this Docling agent will work on top of our locally installed LLM, or it should download LLM by itself? Okay.
Well, I mean, it depends. I mean, we basically can have this. We either connect to LM Studio or, these kind of so you have your local LLMs and it can just call those,
Oh, do we have the pipeline option? Do we have pipeline option to integrate in that agent architecture? I mean, like you in the Docling documentation, there is a VLM pipeline with remote model option is there. We can call our remotely installed Docling model, and we can do the extraction. All right. So
yeah, exactly. So that one should all be possible. For the LLMs, I think, as I said, like it's still work in progress. I don't know to what extent, because the guys have been working on it. I haven't looked at the latest code yet. If we can already connect through this Open API, OpenAI
right.
conform API. It's always like a breaker, but that's kind of the idea, right? So and Malaya does that for a certain extent. To a certain extent, we'll have like a bunch of I would say more LLM backends, right? With light LLM and stuff like this, and it's work in progress. But that's kind of the goal of the project. Yeah.
Any tentative timelines for that from your end?
Yeah, our timelines are always like hopefully yesterday, or the best would be yesterday. It's good today, and tomorrow is too late. So we're trying to go as fast as possible, basically.
Got it. I have one more question on the Docling extractor library. So when we are trying to use that sample code in the from your project, so it seems it is downloading the model directly into my local. Instead of that, I would like to use a locally installed Granite model. I mean VLM model. Can we use that?
You should be able to use it. Again, I cannot remember all of it, but in principle, yes. And if not, we should just add a patch that you can do that. Yes, that this should not be. It should definitely be part of the design. Yes.
Yeah, but because as per your sample code, I'm not seeing that VLM options. Directly it has. So that's where. Is there any way to provide some documentation on that?
Yeah, we will try to add that. Yeah, absolutely.
Yeah. Okay. Thank you, Peter. Thanks so much.
No worries. Easy.
Peter, Jean-Marie speaking. I still have to receive anything from my registration on the cloud.
Yeah, I will need to follow up on that one. This is a more an IBM internal thing. That's just like we need to figure out some issues with the MCSP metering. Okay.
Because I need to get access if I want to see if I
modify
something on my side. Okay.
Yeah.
Okay. Thank you.
Sounds good. And I see still one other Pierre-Jean situation.
Yeah, thank you. One question about Docling agents. I'm just wondering if you have an idea or a feature made to enforce access control or something like role-based constraint to access documents.
Or not yet, maybe. But it looks like a good idea. Yes.
Okay. Not yet. Okay.
No. I mean, again, this is it's still a sandbox. We're working on a lot of different things, but
I understand
happy to see those coming in. Yeah, absolutely.
So will it be available as a plugin for ICN or case manager applications?
Sorry.
I mean, this agent can be available as a plugin for Content Navigator or Case Manager.
Yeah, absolutely.
Oh, great.
Yeah.
Great.
Any other thing?
Great. If that is.
Your has to scroll up.
I think he already asked.
I already asked. Sorry.
Great. Thank you so much, everyone, for attending. We will send out the recordings as quickly as possible, and we will try to attach these slides for it as well. But if you have any questions, definitely reach out on Slack or Discord or LinkedIn, and we will get back to you. Thank you very much.
Thank you.
Thanks. Bye.
Bye-bye.
Bye.